let's get a little practice here. We just learned about sine, cosine, and tangent. Learned a thing called SOHCAHTOA. You know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent opposite over adjacent. We've seen that we can find lengths and find angle measures, and that's what we're going to do, a little practice right here. Pablo, that's Pablo right about there, I guess, sights the top of a tall monument 1,000 feet away. He measures, Pablo carries a protractor with him. Pablo measures this angle of elevation from the horizontal to the top of the tower to be 18 degrees. Find the height of this monument. Yeah, let's call it M for monument so we can talk about it quickly and easily. And I know we're going to use a little trigonometry here. I'm going to think SOHCAHTOA for a minute. Just so I have something to point at as we're making these decisions. What do I know and what do I want to know? If I concern myself with this 18-degree angle, figure this edifice is perpendicular, so we got a right triangle. I can use right triangle trigonometry. I wish I knew the opposite leg, and I do know the adjacent leg. I do know the adjacent. I wish I knew the opposite, and opposite and adjacent are to include me to tangent. So we're going to make a couple statements about the tangent. One's from my diagram. What would you say is the tangent of 18 degrees according to our diagram? Then we'll hit it with a calculator in a moment. Tangent 18 is given by opposite over adjacent. That'd be m over 1,000, huh? Then I got to say, hey, calculator. Alexa, what's the tangent of 18 degrees? Let's see if she knows it, huh?
Tangent of 18 degrees is 0.3249.
0.324.
Sorry, I'm not sure.
9. I'll check on it, Alexa. Let me clear that. Tangent 18. 3249. We're happy with you. Way to go, Alexa. The tangent of 18 is this, and the tangent of 18 is that. These two things must be the same as each other. M over 1,000 must be the same as 0.3249 over 1. I think I can solve that in my head. 1 times m, that'll just be m. And 0.3249 times 1,000 would be 324.9, huh? 324.9 feet tall. If these were all measured in feet, and they were. So we know the height of our monument, 324 feet. No, 325 almost, 324.9. Nice use of a trigonometry to find the height of a building. And you gotta admit, that's a pretty powerful tool. Here's a nice question too. I think there'll be a ladder question on our quizzes that are coming up pretty soon. You certainly want to find distances and lengths too. So, we have a 20-foot ladder, and its base is 6 feet from the building. You definitely want to label a couple of things. This must be the building over here, I figure. And here's my ladder. And it's a 20-foot ladder, is that what it tells me? Yes. Let's label it that way. It kind of looks like the hypotenuse of a right triangle to me. And we know that the ladder is 6 feet from the building. The base of the ladder, here's the building, that must be 6 feet right there. 6 feet, 20 feet. What angle does the ladder make with the ground? The ladder makes this angle with the ground. Let me introduce a little thought to you. This symbol is theta. I'll write bigger over here. And theta is just a cute way to denote the measure of an angle. It's a Greek letter. We'll use theta to talk about angles very often, especially when we're seeking angles. And it's not labeled to be A, B, or C, but so I'm going to call it theta. And what do I know about theta? Do I know its sine, or its cosine, or its tangent? Like SOHCAHTOA again, I've already got it in my head. I know the adjacent leg for theta, and I know the hypotenuse. So I gotta use the function that uses adjacent and hypotenuse, and that's going to be cosine. So I'm going to make a statement about that. The cosine of theta, according to my diagram, is the adjacent over the hypotenuse, so that'd be 6 over 20. Now we could call that 3 over 10, but we don't really have to. So what about theta itself? arc cosine, the left-hand side, destroys the cosine. You'll just be left with theta. Theta will equal the arc cosine of 6/20, which ought to be written this way, which I think you ought to do. Pretty soon we'll skip this step. We're going to go right to it. But right now, let's say the arc cosine of 6/20. Give me the angle whose cosine is 6/20. This is the angle whose cosine is 6/20. And my calculator happens to know about that too. The arc cosine of 6 divided by 20. Oh goodness, I got it wrong again. Clear that and put a pair of parentheses there. Now I got it. The arc cosine of 6/20. What did I do wrong? Let me go to it. Oh, I got 2 parentheses on there. Let me fix that. I can do that better. Oh goodness. The arc cosine of 6 divided by 20. Try that again. How about 72.5 degrees? That's what that ought to be. 72.5 degrees. Find the angle that the ladder makes for the building. That's this angle, huh? I'm going to call it alpha. That's another Greek letter. We like to use Greek letters when we talk about angles. And I understand that it should be the complement of theta. 90 went there. These would have 90 to share, but let's get a little practice with this stuff, okay? So just concerning yourself with that 6 and that 20, what could you say about alpha? Could you tell me its sine, or its cosine, or its tangent? I know the sine of alpha. Sine is opposite over hypotenuse. So, what would be the sine of alpha? Write that. According to my diagram, according to my picture, the sine, which I know is opposite over hypotenuse, so therefore the sine of alpha would be the opposite over hypotenuse. That'd be 6/20. I've got to find the angle whose sine is 6/20. Alpha will equal the arc sine, the angle whose sine is 6/20. I'm going to do that right away. The arc sine of 6 divided by 20. Goodness, I get something silly in there every time. But now I think I got it pretty close. Close those parentheses, and the arc sine of 6/20 gives me 17.5 degrees, I guess. And these are looking pretty good, huh? If I took that 17.5, and I added to it the other angle that we knew about, which was 72.5. Yeah, they're adding that up to 90 with another 90 there. So I'm happy with that. This thing that works out as it should. Hey, by the way, how far up the face of that building does the ladder reach? What is this distance right here, huh? I guess that's what it's asking, huh? We already know these others. And you say, well, I could use a Pythagorean theorem. I said, well, we'll do that too, but let's do it with some trigonometry first. Let's call it, I'm going to call it Z, just so we can talk about it. Let's use trigonometry first. I'm going to use this 72.5 degree angle. It isn't exact, but it's pretty close. So what do you know about this angle in terms of Z? Well, could you use the sine or the cosine or the tangent as I concern myself with this angle? I wish I knew the opposite, and I do know the hypotenuse. I could also do it with the tangent because I know the opposite and adjacent. But I'm going to go with sine. The sine of 72.5 degrees, which was the sine of theta, the value of theta. According to my diagram, when we're finding lengths, I do it once with a diagram, then once with a calculator. We get a 7 equal to each other. The sine of this angle is opposite over hypotenuse, therefore Z over 20. Then I hit my calculator and say, hey calculator, what do you think about the sine of 72.5? Happily they'll tell us the sine of 72.5 is about 0.9537. Since these two things equal the same thing, they both equal the sine of this angle, then it must be true that Z over 20 is equal to 0.9537 over 1. We could cross multiply and solve that quickly, couldn't we? 1 times z, just z, is equal to 20 times the sine of 72.5 degrees. 20 times 0.9537. I'm coming up with 19 point, I'm going to round that to the nearest tenth, 19.1. Yeah, it's going up pretty far up that ladder. It's reaching 19.1 feet up the side of the wall. Now, let's hit it with the Pythagorean theorem, so that worked pretty good. Maybe you could watch this and maybe you could do it yourself. I'm going to go with 19.1 squared plus 6 squared gives me this value. I'm going to take the square root of that amount, and that ladder should have been 20.02 feet. We're off by a tiny bit. It's a 20-foot ladder. This gave me 2/100ths of it. Not much more, huh? So a little tiny error, not bad at all. Trigonometry is really a powerful tool. I'll write a stack of questions that you can work too, or get them out of a book.